Was there another universe before ours? The mind-boggling discoveries of the James Webb Telescope now leave no doubt that our understanding of the cosmos is incomplete. Webb keeps finding astonishingly early galaxies that are far too developed for their age and which consequently push our current models to their limits. Against this backdrop, more and more experts are now abandoning the established idea of the Big Bang and consider it more likely that it was neither the beginning of everything nor a unique event. Today, we show you which Webb discoveries have turned our cosmological worldview upside down, and why we may even have found concrete evidence of a previous universe. Even in the world of astronomy, there are things that shouldn't really exist. After all, the James Webb Telescope has already added many structures to the star maps that most experts openly describe as impossible. Of course, there are the so-called universe breakers that started the current research crisis in the first place. In fact, in early 2023, Webb discovered 6 conspicuous red points of light in a section of the sky near the Big Dipper, which turned out to be very early galaxies whose light had been traveling towards us for more than 13 billion years. And although these objects existed just 500 to 700 million years after the Big Bang, they appear almost as star-rich as our Milky Way is today. Strictly speaking, this should not be possible. Our theories on matter density in the early cosmos suggest that there simply was not enough matter at that time to form such massive galactic premature babies. The situation is very similar in the case of Jade's GSZ 14-0, which Webb discovered shortly afterwards, and which is nothing less than the oldest known galaxy in existence. In detail, this star cluster already existed 290 million years after the Big Bang, and once again appears far too large and heavy for its age. Added to this is a fact that researchers also found possible evidence of oxygen here, which means that several generations of massive stars must have already formed and died out at that time. The galaxy Z of U DS7329 discovered by Webb, which existed just 800 million years after the cosmic birth, actually contains more stars than our Milky Way does today, leading some experts to conclude that it must have formed without dark matter. However, this theory also stands in stark contrast to our understanding of galaxy formation. What is certain, however, is that we simply cannot explain how all these early galaxies managed to reach stages of development that we would not expect to see until billions of years later, just a few 100 million years after the Big Bang. The same applies to the so-called Big Wheel, which entered the cosmic stage when the universe was only 15% of its current age and yet was already 5 times more massive than our home galaxy is today. Was there another universe before ours? And so it is that the first experts have already begun to sound the death knell for our standard model of cosmology. After all, it's simply incapable of explaining the existence of Webb's discoveries. But what could be the solution to this impossible puzzle? Well, that always depends on who you ask. Some researchers believe it is likely that the universe is actually much older than previously thought. Among them is Rajendra Gupta from the University of Ottawa, who concluded in a research paper a few years ago that the universe did not originate 13.8 billion years ago, but 26.7 billion years ago. The author of the study came to this conclusion when he developed a new model in which he interpreted the redshift of light as a mixed phenomenon rather than attributing it solely to the expansion of the universe. And there is no question that the galaxies found would have had more than enough time in 26.7 billion years to grow to the dimensions observed. However, there is also no question that this is by no means the only approach to approaching the ever-new mysteries of space. For what if we were wrong about something even more fundamental? In other words, what if the Big Bang did not take place much earlier than previously thought, but in fact did not mark the literal beginning of everything, and merely the transition from one cosmic chapter to the next? What if the much-cited Big Bang was actually more of a big bounce? Well, then we would have arrived straight at the core of a cyclical universe that is subject to a constant interplay of destruction and rebirth or contraction and expansion. And the fact that this cyclical worldview is currently gaining more and more followers is not only due to the puzzling discoveries of the James Webb Telescope, but also simply because the Big Bang theory alone is unable to answer some fundamental questions. Basically, we assume that in the Big Bang, all matter and radiation in the cosmos were concentrated in a tiny point, a so-called singularity. This primordial seed then expanded explosively 13.8 billion years ago, creating space-time, the fundamental forces of physics and all matter. But what actually caused something to suddenly emerge from nothing at that moment? Can anything come from nothing at all? And was there a trigger for this? Or was it pure coincidence? Well, Stephen Hawking took a clear stance on this and summed up his view of things as follows. Quote, "Because time itself began with the Big Bang, this is an event that cannot have been caused by anything or anyone. The laws of nature themselves tell us that the universe can have come into existence without any energy or cause. The question of what was before the Big Bang is just as meaningless as a question of what is north of the North Pole. What problems does a cyclical model solve? And yet, there are quite a few experts who doubt this very idea. After all, the question of how and why the universe came into being is compounded by the question of its strange uniformity. No matter where or how far we look, on a large scale, there are similar densities and distributions of galaxies, gas nebula, and radiation everywhere. The prevailing theory points to cosmic inflation, and thus to a fleeting era of superluminal growth shortly after the Big Bang. But what solutions does a cyclical model actually offer to all the questions surrounding the origin of the cosmos? Well, in principle, the problem of causality is irrelevant in this context from the outset. If matter has always existed in an eternal cycle, we no longer need to ask how it could have arisen from absolute nothingness, because then it would never have existed in the first place. The mystery of the homogeneity of the cosmos would also be a thing of the past. While it remains controversial whether cosmic inflation really took place, and whether this would not have necessitated the creation of vast numbers of parallel universes, the cycle simply resolves this issue with cosmic contraction, which distributes practically everything equally. We would also no longer need to search for the cause of the Big Bang. It would simply be the end of the previous cycle, which is inevitably followed by a new phase of expansion. And while the corresponding model is currently enjoying ever-increasing popularity as mentioned above, it has its most prominent proponent in Roger Penrose. In fact, the British Nobel Prize winner in physics is also convinced that the universe will continue to expand until at some point all matter will disintegrate and become light. This extreme environment, in which nothing has any reference to time or space in turn, always leads to the universe exploding into a new existence. An exciting discovery. Do these objects originate from our predecessor universe? And while this idea sounds extremely exciting on paper, Penrose claims to have found real evidence that the cosmos is a cyclical character. More specifically, he's referring to the strange signals that he and his colleagues discovered in the cosmic microwave background, or CMB for short. Basically, the CMB is a remnant of radiation that was created about 380,000 years after the Big Bang and still fills the entire universe today. Penrose believes he has found a series of groundbreaking structures in it that originate directly from our predecessor universe. Specifically, these are circular spots that were hidden in the data from Planck and WMAP satellites and correspond to multiples of the average CMB temperature fluctuations. And why the discovery of these so-called Hawking points could be so significant becomes clear when we consider what, according to Penrose, happens at the end of each cosmic chapter with supermassive black holes. These would then evaporate completely into Hawking radiation, but take all the radiated energy with them into the subsequent cosmos in the form of a single Hawking point. The photons produced in this process scatter in an expanding region, but they are not released until they finally appear in the microwave background radiation of the next universe. In theory, this region would then look to us like a disk with the diameter of our full moon. And now guess what the spots look like that Penrose found in reality in the CMB sky. But do Hawking points really provide irrefutable proof that our established idea of the Big Bang is wrong, and that we actually live in a cosmic world that has been collapsing and re-emerging for eons? Well, it's not quite that clue-cut. After all, Roger Penrose's interpretation continues to be questioned by other researchers. Nevertheless, these ominous structures show that there are things out there that give rise to spectacular conclusions, and that the universe could ultimately be much more wondrous than we ever thought possible. And if you think it's possible to join us regularly from now on as we set out to uncover the greatest mysteries of the universe, simply click on the subscribe button. We'd love you to become a part of our community so you never miss another video from us again. We'll see you soon.